Good morning. My topic for TikTok of microprocessors and microcontrollers is H-Earth Heterogeneous Multi-Core Platform Energy Management. The content in this TikTok is introduction, instructions of the heterogeneous multi-core system, and we can see differences between the heterogeneous and homogeneous multi-core systems and the advantages and disadvantages of the hetero and homogeneous multi-core system, and we can see the applications of the heterogeneous and homogeneous multi-core system in this given PowerPoint presentation. Introduction. Today, more than ever, energy and power distribution on heterogeneous multi-core platforms have immense influence on hardware and software architectures because of general tendencies towards energy efficient solutions. There are many experiments which have been conducted using customized. Number 1, Eclipse based integrated development environment, also known as IDE, the tool chain in which it has a compiler, an assembler, linker, and which is used for development for the particular target platform. And third one, true RMS multimeters used for measurements. Here the energy and power distribution on heterogeneous multi-core platforms have very much influence on software and hardware architectures because it has tendencies towards energy efficient solutions. Here is the picture of architecture of multi-core processors. There are processor 0 and processor 1 which is connected to the system bus, and system bus is connected to the main memory. In processor 0 there are two cores, core 0 and core 1. In processor 1 there are core 2 and core 3. Here is we can see the architecture of multi-core processors. It has two processors, a system bus and a main memory in the multi-core processor. Instructions. Instructions energy consumption on a heterogeneous multi-core platform. Here we can see the in the hardware system the energy consumption on heterogeneous multi-core platform is in hardware. Number 1, power and energy. Number 2, energy distribution. And number 3, energy metering. And the instructions energy consumption on a heterogeneous multi-core platform for the software and its engineering is number 1, software notations and tools. Number 2, development framework and environment. Number 3, software system structures. Here in software system structures there are two types of softwares. Number 1, embedded software, and number 2, real-time software. In hardware and software the energy consumption on heterogeneous and multi-core platform plays a major role. Here we can see the processor, multi-core processor. In this picture we can observe that there are two processors, processor A and processor B, and both are connected to a unit known as messaging unit. In processor A, peripheral bus is connected to messaging unit, and also processor B, peripheral bus is connected to messaging unit. In messaging unit, there are registers, status and control registers, sync and control registers, and generate interrupts. There are three types of registers in the messaging unit connected to each other in the both the directions. TX by RX register, status and control registers, sync and control registers, and the status and control registers is connected to the general interrupts. Here the interrupts to the processor B interrupt controller. Here the interrupts to processor A interrupt controller. The differences between hetero and homogeneous multicore. The main differences are in homogeneous multicore systems, system have more than one core and share the same architecture and microarchitecture. And the example of homogeneous multi-core system is ARM quad-core Cortex A53 system. Each core is identical in this system. And in heterogeneous multi-core systems, the difference between in the homogeneous multi-core system across heterogeneous multi-core system is in this system we have two or more cores that differ in architecture or microarchitecture. Example of heterogeneous multi-core systems. In the combination of a microprocessor core, here we can see the example of heterogeneous multi-core system is it has the combination of microprocessor core with a microcontroller class core. For example, mix of Corte, Cortex, Cortem or DSP cores. The main difference between hetero and homogeneous multi-core is in this heterogeneous, the system have two or more cores that differ in architecture or microarchitecture. In homogeneous multi-core system have more than one core and share the same architecture and microarchitecture. Here we can see photovoltaic cell, single ISA heterogeneous multi-core embedded processor, mixed critically workload. In photovoltaic cell, the energies conversion and storage module, mixed critically scheduling framework, also known as MCSF. Here we can see the chip connection between big core cluster and small core cluster. In mixed criticality schedule system framework workload, timing centric task graph set, throughput centric multi threaded application set. Advantages of homogeneous and heterogeneous multi-core system. A CPU that offers multi-cores perform significantly better than a single core CPU of the same speed. Multi-cores allow PCs to run multiple processes at same time with greater easier way, increasing the performance when multitasking or under the demands of apps and programs. Disadvantages of homogeneous or heterogeneous multi-core system. It is much cheaper to buy a single processor system than a multiprocessor system. There are multiple processors in a multiprocessor system that share peripherals, memory, etc. It is such more complicated to schedule processors and impact resources process. Applications of multi-core processors. Multi-core processors are commonly used in many current computers, smartphones, tablet devices, and make our devices to run faster. Application layer various software layer mapping and short scheduling model, hardware layer multi-core platforms. Thank you.